some of the future of manufacturing and aerospace. Thank you. Okay. So the Aerospace Automation Consortium mainly started due to the F-35 manufacturing requirements. The F-35 is a very complex, technologically advanced aircraft. It also went through some weight savings initiatives a few years ago that really took out a lot of the tolerance, the part tolerancing from the supply base all the way up through the assembly process, and that removed some of our manufacturing tolerance. Also, the aircraft is it's a stealth aircraft, which requires very tight control when we assemble the panels, the skin panels with the steps and gaps. And the maintainability of the aircraft is also a key requirement for the Air Force. And what that forces us to do is place very accurate hole patterns within certain skin panels of the aircraft so that those panels are actually interchangeable amongst aircraft. There is also a production rate of 1 aircraft per day, and with something this complex, that's quite the feat to try and maintain our factory, keep it within our footprint, and also make our work in process minimal so we can deliver products to the customer in a timely manner. And then, of course, you might have seen some news articles. The F-35 is getting more expensive, and that's yet another requirement placed on us by our customers, is we've got to do all this work and try and make the aircraft continuously affordable for not only ourselves but our international partners. So when you start combining different requirements for accuracies, complexities, trying to save cost and span time, that leads to a lot of automation. And Northrop Grumman recognized that there was going to be a very significant investment in automation systems for drilling, milling, fiber placement, those type of activities, not only at Northrop Grumman, but also with Lockheed, BAE, and then some of the international suppliers. So we looked at a few of our options, and the first one is to just purchase what's already available. And in order to meet the requirements of the F-35, the equipment that was currently available turned out to be very, very expensive, and also didn't quite automate in areas that we wanted to automate, and I'll talk a little bit about that later on as an example. So another option was for Northrop Grumman to spend our own research and development money to build up the technology to where we needed it to be for precision drilling and fiber placement activities like that. Well, Northrop Grumman has taken the stance that we don't really feel that drilling holes and carbon fiber placement is a discriminator for us to win future programs. We simply want to utilize the best process available, and in order to do that, we look at our innovative supply chain to create this equipment, and they can continue to own it, and they can continue to sell it to other groups and companies. We just simply want to use it. So that kind of led us to the third option, and this option was basically a closer collaboration with our supply chain and with the technology providers and the systems integrators in order to help them define where to spend their own research and development money, so that when the time did come for us to require this equipment on F-35 for full-rate production, the technology was available. So that led us to the Aerospace Automation Consortium. One of the objectives of the Aerospace Automation Consortium was to identify some of the common aerospace challenges, not just for F-35, but across the board with our peers, Boeing, Lockheed, Airbus even, and understand some of those challenges. A few that bubbled up to the surface right away were more accurate drilling and lower cost equipment, also lower impact to our facilities, less foundation work, less environmentally controlled rooms. And so with that, we wanted to look at some of the research and development activities that are out there, because we know that multiple companies are probably working on some possibly similar activities, and we wanted to help align them to maybe even work together to come up with an even more cost-advantage solution. And with all that new technology entering into the the production floor at Northrop Grumman, we also knew that we had to address the workforce challenges. We needed another level of employee and workers that could maintain and operate the new advanced automation that's coming down the shop floor. So with the history of it, the first AAC was held in El Segundo, and we invited various technology specialists, systems integrators, academia, also professional societies such as SME. And what we wanted to do was get them all together and really emphasize teaming and partnerships amongst our supply base and have an open forum and open collaboration effort to be able to start to address certain specific issues, especially on the F-35. And also our collaboration with the professional societies, we were able to start to participate in conferences such as these that most people already attend. We were able to utilize that infrastructure that was already in place to have some of these workshop sessions to collaborate with not only our supply chain and systems integrators, but also our peers too. So some of the outcomes of this is we were able to help the supply base understand the needs of the aerospace automation world and some of the specific challenges relative to F-35. And we were able to kind of establish a working level relationship amongst these groups, and it turned out to be beneficial to a numerous amount of companies. Northrop Grumman, for instance, not only benefits from the end product technology, excuse me, but also the supply chain and the supply base were able to find new partnerships. Oh, excuse me. Thank you. New partnerships, new technologies. Thank you. And so some of the systems integrators were able to expand from some of their core processes by finding partnerships at the Aerospace Automation Consortium for some of these technologies. So on to some of the more interesting, in my mind, the case studies on what we accomplished. As I mentioned before, one of the primary areas that kind of bubbled up to the surface was more accurate drilling. We needed to be able to put those hole patterns in that F-35 skin to accuracies that, I'll just say, when we measure them with a laser tracker, we still question if they're in the right spot because they're very tight tolerance. So out of the robotic drilling systems, there was kind of two areas. One was extreme accuracy, and two was extreme accessibility. The picture shown here is actually some equipment that's being constructed currently by Kamau in Detroit, who is classically an automotive assembly line maker. And this technology utilized articulated arm robots, and we're actually taking these systems and going inside the air inlet duct of the F-35 to drill and countersink the holes, which are currently done as a manual process with drill templates and multi-reaming processes with separate countersinking processes. And so this was one of the first items that we brought up at the Aerospace Automation Consortium, and through the collaboration with the different technology groups, technologies such as this were able to be formed and kind of come out of the relationships that we were able to establish. This is it's a laser-guided, actually has a laser tracker on one side, a drill robot on the other. But some of the other technologies that we were also able to work with the robot OEMs such as FANUC to now start putting external encoders on the robot to make the robot itself more inherently accurate, much like a conventional machine tool.